Well, hello and welcome to another episode of our Equity and Industry Analysis series with Chris Thompson from eResearch, a company that provides periodic and timely insights that help investors build robust portfolios. Today, we are going to discuss eResearch's recent report on Scandium. Chris, as always, it's good to have you with us.
Thanks, Munir.
So you've recently written a comprehensive 39-page industry report on the scandium market. You called it a metal for the green future. What does the report cover?
Yeah, the report covers the sort of an overview of scandium itself, the supply and demand and pricing, the uses of scandium, because most people don't know what it's used for. We do a quick overview of 17 mining companies in the scandium space, from exploration all the way up to producers. And we divide it by the different categories by the stages they're at. And for the companies with resources, we also provide the resources so you can the investor can look at the different companies and compare the resources between the companies. One company we spotlight, which is Imperial Mining Group, they have a 5-page overview in the report. They are a PEA stage company with a scandium project in Quebec, with a net present value of the project is about $1.7 billion over a 25-year mine life. And so they're trying to move into the next stage of feasibility. And they just recently upgraded their NI 43-101 resource as well. And so they're working on their feasibility study, permitting, et cetera. When you look at them in comparison to their peers, we believe that they're a little undervalued. And they also, but they did sponsor this report to be upfront to help defray some of the costs of the report.
This is very interesting, and I know many of our viewers would like to know a lot more about scandium. Can you tell us more about its uses and applications?
Yeah, so scandium is not as sexy as some of the other metals out there, but it is a rare earth. It's on the atomic number 21 on the periodic table for those science guys out there, and it's the lightest of what they call the transition metals. It's usually grouped with the rare earths, and it's a lightweight metal, and that's what's part of its importance and why it's part of the green future. In addition, it has a very high melting point and is a very good conductor of electricity and heat. And why it's important for a high melting point, as well as being light, is typically it's alloyed with aluminum to create a scandium aluminum alloy. Kind of very similar to how niobium is alloyed with steel. It makes it lighter, stronger, and corrosion resistance. So it has some really great applications in aerospace, aviation, defense, automotive, anywhere where you're trying to reduce the weight of the vehicle, but yet have it strong. Especially in things like electric vehicles, where they want to have a lightest possible chassis to get more miles from the same battery. In addition, a really interesting application is that this scandium aluminum powders, the alloy powders, can be used in 3D printing of complex metal structures. And so when you are doing that, there's an example of a company called Relativity Space, and they actually print rocket fuselages using the scandium aluminum alloy powders. So it's very interesting technology and a great use of scandium themselves. So right now, scandium is pretty much used in scandium aluminum alloys or for solid oxide fuel cells, as well as it's also used in things like some ceramics and electronics and lasers, et cetera. Scandium is so important. It is on the critical minerals list for Australia, Canada, the EU, and the United States.
Those are very good uses and applications, powerful ones, really. But you just mentioned that scandium is not one of the most attractive metals out there, even though it's listed among the critical minerals. But so why now? Why are you focusing on scandium now?
Yeah, so there's two reasons, supply and demand right now. And this is where things are changing in the scandium market. On the demand side, right now, there's a demand for 20 to 30 tons of niobium a year, sorry, of scandium per year. That was for the 22 year from the US Geological Survey. If we compare this with niobium, niobium has 79,000 tons per year that are used, and that is more than 2,000 times the difference of demand. And so what we're seeing is a growth in things like aerospace, automotive, and offshore wind turbines that are creating a demand for scandium. And so if we look at just a 0.1% increase in using it in aluminum production, and we used even just 0.5% of scandium, we're talking about 345 tons of scandium demand out there just for those applications, which is 11 times the current amount. So the demand is there. Some estimates have that by 2030, demand from aerospace, automotive, wind turbines, and the solid oxide fuel cells should be about 500 tons. So in the next 7 years, you're looking at a 10 times or more increase in demand for scandium. As I mentioned before, like applications like printing rockets using the scandium aluminum powders is a potential. The final one is the scandium oxide fuel cells, and these are ones, if people don't know, it uses hydrogen and hydrocarbon fuels and oxygen to produce electricity, and the scandium in the electrolyte helps to stabilize it and it lets it to perform better. So these are just like 4 basic applications which are coming on stream, which are going to create the demand. Now on the supply side, that's where previously there's been an issue. The market has basically bought everything that has been produced in the past. Now scandium is abundant in nature. It's even more abundant than lead, but unfortunately, it doesn't occur naturally. It's usually sort of combined with other minerals in nature, and it's usually found in concentration with hundreds of different other minerals. So usually, it's produced as a byproduct of another processing or processing of tailings where there's scandium rich where they can process it. And usually in China or the Philippines and Russia are currently the leading producers, right? And so the scandium production, because it's a byproduct, you can't sort of guarantee the amount that's produced every year. But recently, there are some projects coming in on Australia, and also the Crater Lake project by Imperial Mining are one where scandium is going to be the main mineral. And so if they can come up with a production plan and start producing scandium, then this should feed the demand for the scandium aluminum alloys that are out there. And one of the projects that we mentioned, which is Imperial Mining, the Crater Lake has both scandium and rare earths, and rare earths are actually also used in the green economy and electric vehicle motors and have other applications as well. So this project is interesting because it's both scandium and rare earths. In addition, a lot of it has been happening in the marketplace with the geopolitical issues, and companies and countries like Australia, Europe, Canada, and the US are trying to find more domestic sources of scandium. And that's why you're seeing projects in Australia and Canada come to the forefront. In addition, Quebec has a very large aluminum manufacturing industry, production facilities where they produce a lot of aluminum. And so if we could get a domestic supply of scandium, it's a natural fit for the aluminum industry in Quebec.
Thank you for that breakdown, Chris. Very helpful. And there are lots of important use cases that should keep the demand going for scandium. Indeed. Now for the important questions. For investors who are interested in reading the entire detailed report, where can they find it?
Yeah, you can go to eResearch.com and you can download the report. It's downloadable by free from the website. And you can, or you can find it on various broker terminals like CapIQ or Refinitiv. It's loaded there as well.
Wonderful. Thank you very much, Chris, for your time and insights today.
Thanks, Munir.